All right, you guys, polar time. So numbers 51 through 63 on this video here. This is all the polar stuff. Pay special attention to the fact that you will not be allowed to use a calculator for any of these types of questions. I told you this is just like the final. This is like pretty much basically number 51 on the final. So let's talk about this for a second. 3 other points for 1 comma 90. And so if you remember 1 comma 90, that's 90 degrees with a radius of 1. So just remember that this first number is your r and this is your theta. That means you go out 1 radius and you go up 90 degrees. So remember that our degree of rotation always goes this way. So this is 0 degrees, this is 90, this is 180, this is 270, back to 360 or 0. And so let's remember how there's a bunch of different ways that you can name an ordered pair. So what if I went backwards 1, which would be -1, and what if I went around the circle in the correct order 270 degrees? I land at the same exact spot. That's this first blue one. How about the purple one? What if I went backwards 1, which is -1, and backwards 90 degrees? That's -90. Remember, backwards is clockwise, and we always go front-wise when we're going through the unit circle. Okay, last one is what if I went to the right 1, so that's +1 radius, but then I went backwards 3/4 of a circle, which is 270 degrees. That's the last one. So any of these ordered pairs put you at the same exact ending spot, okay? Converting, that was another big topic. Again, I suggest that you guys pull out the chapter 1, which was the polar notes packet, and just kind of read through it to refresh your memory. Otherwise, doing all these problems all at once is probably going to seem a little bit overwhelming. But remember that we have formulas. X equals r cosine theta, y equals r sine theta. Remember that x goes with cos and y goes with sine. And so if we plug in our r and our theta to both of those formulas, you end up with this. And now is when you need to remember the unit circle. So remember, pi/3 is a 60-degree reference angle. So that's 60 degrees in quadrant 1. The x value at 60 degrees, I drew a little picture over here. The x value is 1/2. The y value is radical 3/2. So that's all I did, is I plugged those in and I simplified, and that gives me an ordered pair in, let's see, rectangular form. Let's do the next one. Convert radical 12, 2 to polar coordinates. That means this is rectangular and it wants it in polar. Remember, polar is r theta. So the first thing you have to do to find r is to do this Pythagorean theorem nonsense. So square that, take the square root of the whole thing, you end up with radius equals 4. Then how do you come up with the theta? Because remember that polar is r theta. Then you have to do inverse tan, because it makes a triangle. You can draw this triangle if you want. This would be in quadrant 4 because you're going right radical 2 and down, or radical 12 and down 2. That's why I wrote quadrant 4 here. You can draw that triangle to figure out the theta. We need to do inverse tangent. So remember, it's the y value over the x value. This is the y, this is the x. And yes, you can simplify this stuff. So now you're thinking back to unit circle, where is the inverse tangent negative radical 3/3? You should be thinking and remembering that that's 2 different places. In this case, you look at the original problem to tell you what quadrant to give your answer in. This is quadrant 4. Therefore, the negative radical 3/3 in quadrant 4 is a 30-degree reference angle. It's 11 pi/6. Again, that's probably overwhelming. You might need to pull out this chapter 1 packet and read through it. That would be my best suggestion for you, okay? But here's our r, here's our theta. This is how you write your answer, r comma theta. Let's move on and see what's next. Ooh, writing something in rectangular form. So do you remember do you remember what cis is? C-I-S, cis. That's the abbreviation that we're going to be using, so just remember that kind of thing. What I have to think to myself is cosine of negative pi/6. Well, let's draw a quick sketch of negative pi/6. That means down pi/6. That's a 30-degree reference angle, quadrant 4. What is cosine of negative pi/6? That's the x value here, which is positive radical 3/2. You can simplify that, radical 3/2. What's the sine, which is the y value? This is just negative 1/2 right here, so simplify that. Keep the I in front. Then just distribute your 3 in, and this is how we get our final answer. Remember that there's a formula when you're doing a cis to an exponent, that means you do 3 to the 5th. That's this part. This is all in your notes packet. It's something you should get out and probably read through. And then you multiply the 5 by this degree and by this degree, or that theta. So that's just a formula to get this line right here. You do 3 to the 5th, the 5 comes from right there, and you also make this 5 pi over 6 and this 5 pi over 6. That is the formula for something, for a cis raised to an exponent. 3 to the 5th is 243, and I can draw a picture. I did that over here. Cosine 5 pi over 6, that's 30-degree reference angle in quadrant 2. The x value is negative rad 3 over 2, that's here. The y value is positive 1/2, that's here. And then just distribute your 243 in. Okay, we have a couple more formulas to remember. Remember when we did vectors and stuff? And so the formula here is you multiply, if you're multiplying vectors, you take the lead coefficients here, the 6 and the 2, and you multiply them. And then what do you do with the 30 and the 60? You add them. Okay, so that's a formula. Again, this is all in your notes packet. But 6 times 2 is 12. And then I'm going to do cosine of 30 plus 60, which is 90. And then don't forget the I, sine 90, 30 plus 60. So you're just basically cis-ing it, CIS. And then you have to think to yourself, what's the cosine of 90? Well, at 90 degrees, the x value is 0. And what's the sine of 90? At 90 degrees, the y value is 1. So then just distribute your 12 in, and we're finished. Almost same exact thing here, but with division, you divide the 6 and the 2, and you subtract the 30 minus the 60, which is what gives me 6 over 2 is 3. And 30 minus 60 is negative 30, so that's the degree that I'm doing here for my cis situation. Negative 30 degrees looks like this. I drew it over here so I could have a reference to look at for unit circle stuff. Negative 30, the x value here is radical 3 over 2. The y value is negative 1/2. So cosine of negative 30 is radical 3 over 2. Sine of negative 30 is negative 1/2. Don't lose the I. And then you just have to distribute your 3 into that. Okay. A couple more things. So number 58 is a little bit more of a complex one, but what I'm going to do first is figure out my r and my theta, similar to how I did earlier in the notes in the review packet. You have to do Pythagorean theorem with this stuff. So remember that what that means is negative 2 comma up 2. And so we're in quadrant 2. That's what this picture looks like. And I need to first do some Pythagorean theorem to figure out what the length of the r is, the radius. That's how I got 2 radical 2. What's the theta right here? Well, it's tangent because it's an isosceles triangle, and 2 over negative 2 reduces to 1 over negative 1, or just negative 1. And what is the theta for tangent in quadrant 2? That's 3 pi over 4. So now I got my r, and I can do cis, and there's the theta, and I still have this 4 exponent right here. So I had to convert this entire ordered pair into polar form and then keep the 4 as an exponent. And now we can implement that formula that I did earlier. I forget what number it was, number 53, no, earlier in the packet, I don't remember. And so remember, that means you take your r and you raise it to the 4th. That's the first thing that you do. And then this 4 gets multiplied by this 3 pi over 4, which is what I wrote here, times 4. The 4's will cancel then, and you just have cis 3 pi. 2 radical 2 to the 4th means you raise 2 to the 4th, which gives you 16. And radical 2 to the 4th is just 4. 16 times 4 is 64. Cis 3 pi. So now you can expand this. That means cosine 3 pi plus I sine 3 pi. 3 pi is around the circle of full time and another half. And so that's negative 1. 3 pi is actually over here. This is going with a different problem, but 3 pi is right here. That means you go around 2 pi and another pi is 3 pi. So this x value over here, again, this picture is for a different problem. But the x value there is negative 1. The y value there is 0. Distribute your 64 and you end up with negative 64. That's a hard problem. You guys can nail it though. There's going to be one of those on the final. You just might have to review and practice a little bit. Number 59. Now we're looking at this graph. Remember, this is a rose. It has petals. And there are formulas for all of those types of graphs. You have those all on a certain page in your notes packet. Hopefully you've got it out and you're looking at it. But when you have 4 petals, that means it's 2 theta. And so remember, if this is an even number, you double it, and that's the number of petals. If this is an odd number, that's the exact number of petals. So if this was 3 theta, that would be 3 petals. In this case, it's 2 theta, which means 4 petals because it's an even number. This is positive cosine because my first petal is right here. So remember, if it was up in the first quadrant, that would be sine. But this one is on the x-axis, which means tells me it's cosine. The length of the petal is 5. There's 5 units this direction. That's kind of the radius type of thing. That's why there's a lead coefficient here of 5. And remember, that's a rose. That tells you what kind of formula to be using. You have a bunch of formulas in your packet to be probably reminding or refreshing your memory of. Okay, convert r equals 4 to rectangular form. Well, r equals 4 means the radius is 4. That means it's a circle. And if you remember from Algebra 2, your circle formula is x squared plus y squared equals r squared. And I already know x squared plus y squared equals r squared because that's polar stuff. So all you have to do is plug in the r, the radius is 4, which gives you 16. Here's another one of those formulas. This one's called a cardioid. If you remember, that means a equals b. This number equals this one. It's because it looks like a perfect heart. Okay, and your minimum number from the origin where this point is right here is 0, and your maximum number from the origin where this point is 6, and that means when you take these two numbers and subtract them, you get 0, and when you take these two numbers and add them, you get 6. That's where the min and the max came from. That's how we learned how to graph this. And again, this is positive cosine because the bulk of the heart is on the positive x-axis. If it was upside down or right side up, that would be a sine cardioid, but in this case, this is cosine, okay? We've got just a couple more. -5 plus 5i in polar form. Again, where does that fall on the graph? So -5 up 5 is right here. We're in quadrant 2. What I need to do is figure out my hypotenuse. So do the Pythagorean theorem and you end up with 5 radical 2. That's the r. That's the length of this side right here. And if I'm going to do r cis theta, I need to figure out what this theta is. Again, if this is isosceles, -5 over 5, you can do inverse tan. The theta there is 3 pi over 4. So leaving it in polar form is r cis theta. The r is 5 radical 2 and the theta is the 3 pi over 4. Okay, last one. This is probably the hardest, most time-consuming one, but number 63, find the 3 cube roots of 27i. So I think what we did in class, if I remember correctly, is that we changed this into this because sometimes it's written with a whole number plus something with an I. But where is 0 plus 27i on the unit circle or on the grid? That's left and right 0 and up 27. So that means right here, and our theta is pi over 2. That's the first thing we need to figure out. First of all, since they are cube roots, that means I'm going to cube root the 27i, which looks like this, and I'm just going to figure out my radius, which this is Pythagorean theorem. You know how to do that. However, I know that this is already on the axis, so the radius here is exactly 27. That's how I graphed that point. Mathematically, Pythagorean theorem, you can figure out what r is, or you can just look at the graph. Here I went up 27i to graph this point, so the radius is 27. So I have a theta and I have an r, so I can do now r cis theta. But don't forget the 1/3 exponent because it is a cube root. So remember, I have that formula that I'm going to implement the cube root here. So I'm going to plug in my 27 for the radius, and I'm going to plug in my theta, and now I have to distribute, like do that weird formula thing with this 1/3. It means 27 to the 1/3, which is here, and I have to multiply 1/3 times pi over 2. That gives me pi over 6. And you can expand this. 3 cis pi over 6 means 3 cosine pi over 6 plus I sine pi over 6. And you can simplify that using the unit circle. I drew a little picture way over here, and that gives you 3 radical 3 over 2 plus 3 over 2i when you distribute the 3 in. This is rectangular form expanded. This is the cis, the 3 cis pi over 6, or this is polar form. You can expand it and you can simplify it. So there's my first answer. And then if you remember, this is another Algebra 2 thing, but if you're doing cube roots, that means you should have 3 answers. That's the hard part, is to remember, okay, that's one of the answers, and maybe on a multiple choice final, you guys, maybe all the answer choices, this one only appears once. that tells you what the answer is. But remember, if it's a cube root, not a 3 exponent, but a 1/3 exponent, that means you have 2 more answers you need to find. So we have this thing called spacing, and that means that our answers are equally spaced around the circle. So I have to do 2 pi over this 3, which is from cube roots. That's where the 3 comes from. 2 pi over 3 for the spacing, okay? And so what I need to do is take pi over 6 and add 2 pi over 3 to it, which gives me, after a common denominator, 5 pi over 6. That's my second answer. Now I need to add 2 pi over 3 again, which gives me 9 pi over 6. Yes, that reduces. That's my third answer. So these 3 answers are the 3 answers in polar form. You might have to expand them like I did here. I did the first one expanded. You could very well do that with 2 and 3, depending on how the answers look on the test. Thanks for watching the polar video, you guys. Hopefully that was helpful. Bring questions to class and ask me some stuff, okay? Have a great night. See you tomorrow.